Okay, so with this one now, we're going to explore how pointers are used so we can understand again how addresses are assigned to variables. Okay, so let's save this file for this example for var exe3 .c. Make sure it's a .c file. So let's save it. And as you can see here, I wrote the framework on how this is going to work. So I have a function main. I have a function system with the argument pause to hold the screen. Main returns an integer, so that 0 that you're seeing here is what this function main returns back to the operating system. Just a quick review as to why we write all this. Our code is going to run within main. We will learn in the future how to run code outside of main with other functions. Our next lecture, however, we're going to learn how to declare variables either locally or globally. But right now, we want to learn how pointers work, at least locally within main, right? So when you have a variable within main, let's do this, int a, and let's assign it a value of 8. We've learned a couple things. I can actually print the value of a, so I can actually see something like this. A equals, and we can put a %d here. Let's put a /n to get a new line, and that would be simply a. So we can compile and run this. This will give me the value stored in a. So let's do that quickly. Compile and run. And there you have it. So a is equal to 8. Now, again, what if we wanted to know where a is in memory? Then we'll do something like this, printf. A is at this address, and that's where you're going to store the 8 that we're handling there. So A is at this address, which means inside that address, starting at that address, we have 4 bytes reserved for storing 8. Okay, so that would be a %d /n. And remember, this time, and %a to look at the address. So let's go ahead and compile and run this. And there you have it. Now, how many bytes were reserved for a to store that 8? We could do that as well here. So printf a, or a as a variable. So a is a variable, not just simply a letter a. Occupies %d bytes where, and we're gonna show the value %d is stored at %d. So this is going to be fun. We're going to show three things here. So one will be size of, and that would be a, right? So comma, next item, a itself, and then n %a. So this here sums up what we've done with the previous lecture. Okay, so we want to know how many bytes, what's in a, and where is a. So how many bytes is the size, what's in a, that simply is a, and where is a, and that would be n %a. Okay, so let's go ahead and run this, compile and run. And there you have it. So a occupied 4 bytes, where 8 is stored at this address. So I hope now you're getting some sort of bearing, some sort of a situational awareness as to how a lives within the function main. A is a local variable that only exists within main. In the future, we're going to see some other functions other than main, written outside of main, and they will have their own local variables. Okay? And then can you declare variables that are not within a function? Absolutely. We're going to see the next video, or in the next lesson, will be about global variables. And then we're going to see the reasons why we would and would not use global variables, and then we get into constants and all that jazz. So for now, I hope you understood here that A, right, occupies 4 bytes, where 8, the value 8, is stored at this address. So this address represents A. So physically in memory, 2293568 is A. What's in it is the payload. It's the value 8. And how much space do you have for it? 4 bytes. So as long as you understand that concept, now pointers will make a lot of sense. Now, what is a pointer? A pointer is basically a place in memory that stores an address that refers to some variables. A pointer, however, if it's going to refer to some variable anywhere, has to be of the same type as that variable. Okay, so what variable do we have here? We have variable A. Can I have a pointer to the variable A? Absolutely. But first, create the pointer. And it doesn't have to point to A yet. So how do you do that? Well, A is of type integer, so our intent is to point to A. We are not pointing to A yet, so I'm going to do something like this, int. And notice the syntax I'm going to use, asterisk. Asterisk means I am creating a pointer. And let's call it my PTR, so my pointer. Okay? Always start with a lowercase when things are a variable. Okay? Later on, we're going to learn about constants. Everything will be capitalized. For now, my PTR, one word, my pointer. Again, it's not this is a variable name, but it happens to be a variable pointer. Now, it's not pointing to A. Let's be clear. It is not pointing to A. If I try to print whatever is in my PTR, I'll get garbage. Okay? And if I try to dereference this pointer, I will also get garbage. All right? So what do we mean by that? So let's say I try to print what's in my PTR. Now remember, if you were just looking at it as a variable, you know I've never assigned a value to it. So really, what's stored in it, it doesn't make any sense. It's not related to any specific procedure. So, and what would be our procedure for this case? Well, we want to tie this pointer to A. Okay? So how do you do that? My PTR is going to be equal to the address of A. So this is what we call the assignment. So this will be the pointer assignment. So just like variables, you can declare them, but if you try to print their content, you're going to get garbage. It's until you put a value in them or you initialize them that you would get something. Let's create another pointer. And you could you have more than one pointer pointing to the same thing? Absolutely. Okay? And that's a lot of fun with pointers. So let's create another pointer. My other PTR. And this time I'm going to assign it, which means I'm not only going to declare it, but I'm going to assign it right from the start. Equals and %A. So you've got two different ways to do it. You could declare the pointer, but it's not attached to anything until you do this. Or you can declare a pointer and don't waste any time and go ahead and assign it to the actual address you want to point to. So pointers, you always store an address in them. Okay? So what's the advantage of having pointers? We're not going to see a major advantage in this lesson in particular, but we will see how it works. We will absolutely appreciate pointers in future lessons when we learn how to pass by reference, when we get into data structures and we have linked lists and all sorts of goodies that pointers can come in to help us organize our data. But for now, notice I have two pointers pointing to A. And can I see what's stored in any of these two pointers? Absolutely. Can I dereference these two pointers and see if indeed they're pointing to A? Now remember, when I run this program, we know A's address. So let's look at what's stored in my PTR. So printf Okay? My PTR equals %d slash n. So for now, we're just going to do that one for now. So my PTR. Let's see what's stored in there. Let me run this. What do you notice? Notice A's address is 2293568, right? So what's in the pointer? The address. So a pointer stores an address. So if it does, what can I do with it? Well, I can dereference this pointer to see the data that it's pointing at. So now we're interested in the actual data at that address. How do you do that? Well, you dereference it. Printf, and let me show you how to dereference. And that would be star my PTR. Now, this is not where I'm running the code. I'm going to show you here where the actual code happens right here, star my PTR. So this is where you would dereference it, right here. So this is really where the execution is happening, is when you're saying that. This here is just showing what we're looking at. So dereferencing the pointer, you put a star in front of it right here, and that value is going to go right here. And let's see what value do we get. So compile and run. And there you go. You get your 8 back. Where did that 8 come from? Well, that was stored in A. Can we alter the value of A with the pointer? Can we alter the value stored in A with the pointer? And the answer is yes. So you'll have to dereference. You could do something like this. Star my PTR, and let's store -2. Okay, now let's go ahead and print A and see if indeed the pointer modified the value stored in it. Now you can see the link between a pointer and a variable. So you can alter indirectly a variable through a pointer pointing at it. So let's go ahead and printf just simply A value after changing it through the pointer. And that would be a %d slash n, and simply print A. And let's see if we get that -2. So now if we do get -2, which we will, we understand that there is a coupling going on, right? So my PTR has an effect on A because it physically has access to that memory location. Okay? So let's go ahead and compile and run. And sure enough, A now has changed to -2. Even though we didn't change A directly, we changed it by dereferencing the pointer and assigning it -2. So in other words, notice in my code, I don't really need to know the address physically. All I need to do is assign the address first, right? So I don't have to peek into memory to extract the address. It's done for me during the pointer assignment. Now here's another thing. Since I have 2 pointers pointing to A, can I actually use my other pointer to look? Okay, that would be fun. So remember, I have 2 pointers pointing to A, so I can actually look at what's stored in my other PTR, so we know it's going to be that address. And that would be a %d slash n. And simply, don't forget that comma here. You're separating the arguments within the printf statement. And that would be my other PTR. Now, this simply will print the address of A. Now, how can we dereference my other PTR with an asterisk? Yes. And that should show us the value that's stored in A. So printf. And that the dereferencing will be star my other PTR is going to be equal to %d slash n. Again, /n to give you a new line. Now, notice this is the key here. This is where you do it. My other PTR. Okay? And let's see how this works. So compile and run. And sure enough, my other PTR dereferenced has -2, which is the value, the latest value stored in A that was modified by my PTR, right? And so when did we modify it? In this line here, right here. Okay, so let me just show you here. This is when we last modified it, the value stored in A, with that -2, using my PTR as a pointer. So again, the key points here is that you have 2 pointers that I declared, 2 different ways to declare a pointer. You can declare a pointer by itself first, then assign it later, which means, and this is an important lesson as well, you can actually take that pointer and point it to other variables, which gives you a lot of flexibility. Let's say you had an int b somewhere and an int c. As long as they're integers, then I can reassign new addresses to my PTR and make it point at will anywhere I want. And that's going to be another advantage we're going to use to leverage code with. But for now, the style that I used, I created a pointer first, which points to nothing yet, and then made it point to A. Or you could do all of it in one line. So I create another pointer and assign it the address of A. So you can have as many pointers to a single variable as you want. Now, would you want that? There are situations where about 2 or 3 pointers might be a good idea, especially when we do data structures. We want to point at something and not lose track of it as we move to something else, etc., etc. So for example, we could be pointing at the previous data and the front data and the back data, the actual data. So in data structures later on, we could use pointers. Just like you would put something in your book as a bookmark, right? And we can come back to that particular location knowing the pointer is there. So pointers can come in really, really handy. So now the lesson again from this is that you understood how to declare a pointer, how to assign it to an actual variable through its address, or how to do it all in one line like this. And the other lesson is you can alter the content of a variable through a pointer. Okay? Very good. So I will see you again for the next lesson.